Imagine for a moment that you are standing on the surface of a planet. You look up, but there is no sun. There is no dawn, no dusk. Just an endless, star-dusted night. The familiar constellations are there, but they are the only source of light. There is no blue sky, no warm sunlight on your face. This isn't a planet experiencing a temporary eclipse or a very long night. This is its permanent state of being. You are standing on a world that does not orbit a star. It is a cosmic orphan, a wanderer drifting alone through the vast, empty expanse between the stars. This is the reality of a rogue planet. So, what exactly is a rogue planet? In the simplest terms, it is a planet that does not orbit a star. Think of our own solar system, Earth, Mars. Jupiter, all the others are gravitationally bound to the Sun. They follow predictable paths or orbits around it. This gravitational leash keeps them in a relatively stable system. A rogue planet, however, has no such connection. It has either been thrown out of a solar system or formed in isolation, and it now drifts freely through interstellar space. It is a planetary mass object, meaning it has enough mass to be round like a planet, but it's a celestial nomad with no permanent home. The journey to becoming a rogue planet is often a violent one. Imagine the birth of a solar system. It is a chaotic place, a swirling disk of gas and dust, where countless small bodies are crashing into each other. Massive planets like Jupiter grow quickly, and their immense gravity stirs everything up. Because rogue planets have no star to provide them with heat and light, they are unimaginably cold and dark places. Our planet, Earth, is a pleasant temperature because it basks in the constant energy radiating from the sun. Without that energy, the surface of our world would quickly freeze over. The oceans would become solid ice. The atmosphere would freeze and fall as snow, leaving behind a barren, airless wasteland. This is the permanent state of a rogue planet. Its surface temperature would likely hover just a few tens of degrees above absolute zero, the coldest temperature possible. It is a cold deeper than anything we can experience on Earth. The darkness on such a world would be just as profound. Here on Earth, even on a moonless night, the sky is never truly black. Starlight, air glow in the atmosphere, light pollution from our cities. On a rogue planet, there would be no sun to rise, no moon to reflect its light, and no atmosphere to scatter faint starlight. The only illumination would be pinpricks of light from faraway stars. The sky would be a perfect velvety black, decorated with brilliant, unblinking diamonds of the Milky Way. Does this mean these worlds are completely dead and frozen solid? Not necessarily. While the surface would be an inhospitable icy shell, deep beneath the ice the story could be different. Planets generate their own internal heat, from the decay of radioactive elements in their core, and from leftover heat from their formation. A large rogue planet, perhaps bigger than Earth, could have a molten core. That internal furnace could warm the planet from the inside out, creating a subsurface ocean beneath thick ice. This opens a whole new realm of speculation. One of the most mind-boggling questions about rogue planets is just how many of them are out there. Because they are so dark and difficult to see, we can't simply count them. Instead, scientists have to rely on complex simulations and on the few detections we have made to create an estimate. The numbers they are coming up with are nothing short of astonishing. Some studies suggest that for every star you see in the night sky, there could be dozens or even hundreds of these unseen rogue planets drifting silently in the darkness. Our Milky Way galaxy contains hundreds of billions of stars. If these estimates are correct, it would mean that rogue planets are the most common type of planet in the universe. They would outnumber the planets orbiting stars by a huge margin. Think about that for a moment. The familiar model of a solar system with planets neatly orbiting a sun might actually be the exception rather than the rule. The galaxy could be teeming with these solitary wanderers, a vast, hidden population of worlds we are only just beginning to comprehend. Our galaxy, which we see as a collection of bright stars, might also be a colossal graveyard of ejected planets and a nursery for worlds that formed in isolation. This implies that the formation of planetary systems is an incredibly inefficient process. For every stable solar system like our own, there could be many more that ended in chaos, flinging their newly formed planets out into the void. It paints a picture of the early universe as a far more violent and wasteful place than we might have imagined. Billions upon billions of worlds, potentially similar to Earth in size and composition, may have been denied the chance to bask in the light of a star. They are the lost siblings of worlds like ours, doomed to a life of cold and darkness before their stories ever truly began. The sheer number of these potential worlds is staggering. If there are, say, 100,000 rogue planets for every star in our galaxy, that would mean there are trillions upon trillions of them in the Milky Way alone. They would collectively represent a significant amount of the galaxy's mass, a form of dark matter in a sense, not the mysterious substance astronomers search for, but dark in the literal sense that they emit no light. The galaxy, it seems, is far more crowded than it appears to the naked eye. It is filled with a ghostly population of planets that we can't see, a silent testament to the chaotic nature of creation. Finding a rogue planet is one of the greatest challenges in modern astronomy. How do you find a small, dark, cold object that emits virtually no light of its own, set against the infinite black backdrop of space? It's like trying to find a single piece of coal in a vast, dark cellar at midnight. Like looking for the dip in a star's light as a planet passes in front of it, simply don't work, because there is no star. Astronomers have had to develop an ingenious, almost indirect method to hunt for these cosmic ghosts. The primary technique used to find them is called gravitational microlensing. It's a phenomenon predicted by Einstein's theory of general relativity. The theory tells us that massive objects bend the fabric of space-time. When a rogue planet, by pure chance, drifts directly in front of a distant star from our point of view, its gravity acts like a lens. It bends and magnifies the light of the background star. For a brief period, lasting a few hours or a few days, the distant star will appear to brighten and then fade back to normal. This temporary brightening is the telltale signature of an unseen object passing in front of it. This method is incredibly difficult and relies on a great deal of patience and luck. Astronomers must monitor millions of stars continuously, hoping to catch one of these fleeting events. The duration and shape of the brightening tell them about the mass of the lensing object. A very short event, for example, points to a smaller planetary mass object, a potential rogue planet. It's a search for a momentary flicker of light, a cosmic wink that betrays the presence of a dark world. It is through these rare events that we have confirmed the existence of rogue planets and started to estimate their numbers. What mysteries do these worlds still hold? We know so little. We don't know for sure how they form. Are most of them ejected from solar systems? Or do they form on their own, like tiny failed stars? We don't know what their atmospheres, if they have any, are made of. And of course, there is the ultimate question. Could any of them harbor life in their dark subsurface oceans? These are questions that will drive astronomy for decades to come. Each rogue planet we find is a clue, a single data point in a vast, dark ocean of unknowns. They remind us that the universe is not only stranger than we imagine, but stranger than we can imagine.